So number 35, we have two neutron stars that are separated by a distance of 1 times 10 to the 10th meters. They each have a mass of 1 times 10 to the 30th kilograms and a radius of that. They're initially at rest with respect to each other, as measured from that rest frame. How fast are they moving when their separation has decreased to 1/2 of its initial value, and B, when they're about to collide? So here we have our two neutron stars, and they start out with some separation distance at 1 times 10 to the 10th. And what's happening here? They're starting out with gravitational potential energy, and that's going to be converted into kinetic. So what's going to happen here? For A, they're going to move to half their distance, which is going to be half of that value. And we can figure out the change in gravitational potential just by taking the difference between those two. And again, remember, it's negative g m1, m2 over one distance minus the other distance. Plugging in or rearranging this, you can simply write, or we can figure out that this is all going to be converted into kinetic energy. How much kinetic energy? Well, 1/2 mv squared, but how much mass is moving? In this case, both of these neutron stars are going to be moving with the same velocity, just because of symmetry. And we can just add their two masses together and solve for this velocity. Now, just a little bit of math magic. Negative b minus a negative a is the same as a minus b, just to make it a little bit easier to visualize. Oops, I took out the masses, not sure why. I'll put those back in just a second. There they are, which gives us our final distance, which is 1/2 of the original starting distance, minus the original distance over all these values. Plugging in, or if you plug in the two masses and solve it, 1/2 times twice the mass ends up just being the mass of one of the stars. And then over on this side, if you plug in g m1 times m2 over this minus that, you'll end up with that value. Dividing both sides by 1 times 10 to the 30th gives us this, and then taking the square root gives us that they'd be moving about 81,700 meters per second. Fast, but not that all exciting. Part B, they're now just about the hit. How far are they apart from each other? Well, their center of masses now are just the diameter, or 2 times the radius, of the neutron stars. So doing the exact same thing, in this case, this is the radius of one of the neutron stars. I'm just doubling it to get the distance between their center of masses. This was their original distance. And again, it's going to be converted into kinetic energy. Again, the 1/2 of the sum of their masses is this. And if you solve this whole side, you get this relatively large number. Giving us that, if you divide both sides and then taking the square root of both sides, you get this, which is nearly 10% of the speed of light. That is booking. Have a good night. I hope this made sense. Good luck.